Hello, hello. Today is where rational exponents can start to look kind of scary. But I want you to keep in mind that you already know how to do this. We learned it when we learned rules for exponents to begin with. So you've already done it. It just looks different. Okay? So you can do this. Take your time. Go slowly. Remember, it's like a puzzle, so you can try lots of things. Always show your steps so I can follow your thinking, because there can be lots of different combinations of ways to apply the rules and still get the right answer, and you're applying them right. All right, so let's get started. Okay, all of these exponent rules you learned before. Product of powers, where if you had the same base, you kept the base, added the exponents. If you had one base and two powers, kept the base, multiplied the powers. Two bases, one power, the power got distributed to each base. Negative exponent, you had to use the reciprocal of the base to make it positive. If you had the same base and they're being divided, then you would keep the base and subtract the exponents. And then last, if you had two bases being divided inside and one exponent, again, you would distribute the exponent. Okay, so this is what it's going to look like with the rational exponents. Let's say you have the problem 5 to the 1/2 power times 5 to the 3/2 power. You're still multiplying same bases. So you're going to keep the base and you're going to add the exponents. So 1/2 plus 3/2 is 4/2. Now simplify 4/2, that becomes squared. So it's 5 squared, which you know is 25. So that problem that looks scary, looks like this, can easily be done without a calculator if you know the rules. Okay, so next one we have 3 to the 5/2 power squared. So you have one base, two powers. You're going to multiply these powers. Now, when you multiply these powers, these 2's, because this 2's on top, this 2's on the bottom, are going to cancel out. So it leaves you with just 3 to the 5th. Now you go over to your perfect squares and other paper. Start at 3 on the left. Go all the way over to the right under the x to the 5th column. And it tells you that 3 to the 5th equals 243. Okay, 16 times 9 to the 1/2. We're going to distribute the 1/2. Now, you should know, like that's just something that you should memorize, is that 1/2 is the same as square root. 1/3 is the same as the third root. 1/4 is the same as the fourth root. So this becomes the square root of 16 times the square root of 9. You know the square root of 16 is 4, the square root of 9 is 3, and then 4 times 3 is 12. Okay, we have 36 to the negative 1/2. So we need to make that 1/2 positive. So we're going to use the reciprocal of 36. Oh, sorry. We're going to rewrite it this way. The square root of 36 to the negative 1. And what's the square root of 36? 6. 6 to the negative 1. Use the reciprocal of 6, which is 1/6. All right, next one. We've got the same base. They're being divided. So you keep the base, subtract the exponents. So 5/2 minus 1/2 is 4/2. Again, we're going to simplify the 4/2 into 2. So 4 squared is 16. Okay, 27 over 64 to the 1/3. You've got two bases to one power. So we're going to distribute the power. And we know that 1/3 is automatically the third root. So third root of 27, third root of 64. Go to your perfect squares paper and more. Go under the x cubed column. You see 27. Go over to the left, it tells you it's 3. Go back to the x third column, find 64. Go to the left, it tells you it's 4. So 3/4 is your answer. Okay, it's important to remember that when you're multiplying fractions, let's say we have 5 to the 7/12 to the 2/3, you just multiply straight across. You don't need common denominators. So you do 7 times 2 is 14, 12 times 3 is 36, and then you want to simplify this. So we can divide both of them by 2, so it becomes 7/18. So this now becomes 5 to the 7/18. Okay. If you are adding or subtracting, you need to have those common denominators. If you don't remember how to do common denominators, then you need to get on YouTube or something and figure it out, okay? All right, so we're going to practice. Let's say we have 4 to the 2/5 times 8 to the 2/5. Now, this is a slightly different rule. Our bases are not the same. However, our exponents are. So we get to keep the exponent and multiply these bases. So it's going to become 32 to the 2/5. Notice I didn't change the power because it was the same. Now I'm going to rewrite this into radical form. Now the 5th root of 32, go to your x perfect squares paper. Under the x to the 5th, you see 32. Go all the way to the right, it tells you it's 2. So now I bring over the power, and 2 squared is 4. Okay, it works the same way this way. If it looks like you're dividing them, and you pretty much have the same exponents. So first thing we're going to do is we're going to take the negative 2/3 and we're going to make it positive by moving the 4 up to the top with the 2, like this. So instead of dividing the 2 and the 4, we're now multiplying the 2 and the 4. Okay, same exponents, so keep the 2/3, multiply the bases. So it becomes 8 to the 2/3. Rewrite it in radical form. We know the 3rd root of 8 is 2, so now we have 2 squared again. So that means it's also 4. Okay, this is kind of like an additional problem. You want to keep using that table. So you want to look at the notes that I have that are not attached to the video. So you can keep looking at those rules as you go through this. Okay, now you're going to have some problems like this that are definitely going to look scary, but I want you to just take it apart. So when you have a problem like this, start where the most stuff is. In this case, it's on the top. Now, we're going to look at the situation that we have here. First, we're going to check out our bases. Are our bases the same? Yes, they're being multiplied. So that means you keep the base, add the exponents. Now, before you can add the exponents, they have to have common denominators. So I can turn the 2 into the 4. So my negative 1/2 is going to become negative 2/4. Okay, so on top, I'm going to keep the 256. 3/4 plus a negative 2/4 is a 1/4. Now, I have the same exponents, so I'm going to see, can I do 256 divided by 81? And when you put that in a calculator, you get something yucky, okay? So we can't do that. So what we're going to do is we're going to turn them each into radicals. So now I have the 4th root of 256 over the 4th root of 81. Go to your perfect squares paper. Under the x to the 4th column, find 256. Go all the way over to the left, you find out it's 4. Go back to your x to the 4th, find 81. Go all the way over to the left, you find it's 3. So your answer is 4/3. You don't need to simplify it into a mixed number or anything, just leave it like that. Okay? All right, so good luck. Remember to get a hold of me if you have questions. Do not just ramble through this kind of stuff and just guess. Ask questions. Ask somebody else. Ask me, whatever. Okay? Good luck, guys. I'll talk to you later.